Today's lesson is dealing with solving multi-step absolute value inequalities. So this lesson will be more of a review of what we've been going through with other absolute value inequalities. So some review work with absolute value inequalities. In order to solve these types of problems, the very first thing you need to do is isolate the absolute value expression. The second step would be to write the inequality as a compound inequality without the absolute value symbols. And we had two key words when we were writing compound inequalities. You use and when the absolute value inequality is a less than. So that's our conjunction. The other compound inequality is a disjunction where we use or when the absolute value inequality is greater than. So let's look at an example. Here, the example is worked out for you. You can see the steps that they have done first. First, they got the absolute value by itself by subtracting 3 on both sides. The second step they did was divide by 2 to get the absolute value of x completely by itself. And then the third step here, they took it out of the absolute value and made a compound inequality to get their answer of -4 is less than x, which is less than 4. And then finally, they graphed their answer. So let's practice one ourselves. Solve and graph this equation, this inequality. Our very first step would be to get the absolute value of x divided by 5 by itself. So I would add 4 to both sides. When I do that, I have the absolute value of x divided by 5 is greater than 6. Our next step, I want to get the absolute value of x by itself. I want to multiply by 5 on both sides. So now I have the absolute value of x is greater than 30. Since it's a greater than symbol, when I take it out of the absolute value, that means it's a disjunction. So I need to write an inequality where I use the keyword or. So I have x is greater than 30 or x is less than a -30. And the final step would just be to graph it on a number line. So I have 0 in the middle, I have 30 on the right hand side and -30 on the left hand side. And since these are both, they just have a greater than symbol, I use an open circle on -30, open circle on +30, and they go away from each other. Let's do the next one. Solve and graph. -10 times the absolute value of x plus 54 is greater than or equal to -21. Again, our first step is to isolate the part that has the absolute value. So here I'm going to subtract 54 on both sides. That leaves you with a -10 times the absolute value of x, which is greater than or equal to a -21 minus 54 would be a -75. Then our last step is to get the absolute value by itself. So I'm going to divide by a -10 on both sides. And remember, when I multiply or divide by a negative number, I need to flip the symbol. So now it's less than or equal to -75 divided by a -10 is a +7.5. Now, since I have a less than symbol here, it's going to be a conjunction. So I can have my x in the middle. X is going to be less than or equal to +7.5, but it's going to be greater than or equal to a -7.5. And then to graph it on a number line, 0 in the middle, negative 7.5 to the left, positive 7.5 to the right. And now I'm going to use closed circles on it because it's got the equal to part on the symbol. And since x is less than 7.5, it's got to go to the left. If it's greater than negative 7.5, it's got to go to the right. So we have a conjunction here. You may work on these next two yourself for extra practice. Second type of example, we have the same type of inequality, absolute value inequality, but the only difference is now we have a operation inside the absolute value. So we're going to do everything the same way. The only difference now is after you take it out of the absolute value symbol, then you have to do the operations. So let's look at an example here. Solve and graph this example. The absolute value of x plus 2 minus 1 is greater than 11. So the first step, I need to isolate the absolute value. So I'm going to add 1 to both sides. I have the absolute value of x plus 2 is greater than 12. Now, once I take this out of the absolute value, since it's greater than, it's going to be an or. So I have x plus 2 is greater than 12, or x plus 2 is less than negative 12. From this point, now I just solve for x. So I'm going to subtract 2 on both sides. So I have x is greater than 10, or subtract 2 on this side, x is less than a negative 14. Now to graph this on a number line, we have 10 on this side, we got 0 in the middle, we got negative 14 on the left-hand side. We're going to have an open circle on negative 14 and an open circle on 10. It says x is less than negative 14. So if it's less than negative 14, it's got to go to the left. And if x is greater than 10, it's got to go to the right. The next example, absolute value of x minus 9 plus 3 is less than or equal to 10. Again, I have to get the absolute value by itself, so I'm going to subtract 3 on both sides. When I do that, I have the absolute value of x minus 9 is less than or equal to 7. And because I have a less than symbol in there, I know it's a conjunction. So I use either the word and or the shorter version. I'm going to use the shorter version, so I'm going to have x minus 9 in the middle. It's got to be less than or equal to 7. On the other side, it's going to be greater than or equal to a negative 7. Now I got to get the x by itself, so I'm going to add 9 to all 3 sides. And when I do that, I end up with 2 is less than or equal to x, which is less than or equal to 16. Now I can graph it on a number line. I'll have my 2 here, my 16 here. I need to have an closed circle on 2 because it's got the equal to sign, and x is greater than 2, so it's got to go to the right, and x is less than 16, so I got to go to the left. Example 3, solve multi-step absolute value, another type of problem. This time we have 2 different operations inside the absolute value. This example, you have a division and you're subtracting. So let's look at an example here. Solve and graph this example. absolute value of 2x plus 1 is plus 5 is greater than or equal to 8. Get the absolute value by itself. I subtract 5 on both sides. End up with absolute value of 2x plus 1 is greater than or equal to 3. Because it's greater than, I know it's going to be using or. So now I have 2x plus 1 is greater than or equal to 3, or 2x plus 1 is less than or equal to a negative 3. Now I have to do 2 steps to solve for x. So I'm going to subtract 1 on both sides. So now I have 2x is greater than or equal to 2. On this side, I'm subtracting 1 also. So I have 2x is less than or equal to negative 4. Next step is to get x by itself, so I divide by 2 on both sides. So here, x is greater than or equal to 1, or on this side, divided by 2, x is less than or equal to a negative 2. So these would be my disjunction answer. And then on a number line, I graph it. I have a negative 2 over here, put my 0 here, put my positive 1 here. I will need to have a closed circle on both negative 2 and positive 1. X is greater than or equal to 1, so it's got to go to the right. It's less than or equal to a negative 2, so it's got to go to the left. Let's try the next one. Here I need to add 9 to both sides. When I do that, I end up with the absolute value of x divided by 2 plus 5 is less than positive 7. When I take it out, because it's a less than, I know I have a conjunction, so I can write the shorter version. X divided by 2 plus 5 is less than 7, but it's also greater than a negative 7. So to get the absolute, or to get x by itself, the first step is to subtract 5 on all 3 sides. When I do that, I have negative 12 is less than x divided by 2, which is less than positive 2. Now to get x completely by itself, I multiply everything by 2. So 2 times a negative 12 is a negative 24, which is less than x, which is less than positive 4. Now I can draw my number line. I'll have negative 24 here. I'll have 0 here, and I'll have a positive 4 here. And we need to use an open circle on both negative 24 and a positive 4. And it's going to go to the left, or to the right, because x is greater than negative 24, and to the left because x is less than 4. And we'll go through one application problem. It says NCAA rules require that circumference C of a basketball used in an NCAA men's basketball game vary no more than 0.25 inches from 29.75 inches. Write and solve an absolute value inequality that models the acceptable circumferences. What is the least acceptable circumference? So I need to write an absolute value inequality. I know inside the absolute value, it says that the circumference, so C, so whatever the size of the circumference of the ball is, it cannot be no more than 0.25 inches in either direction from, so I gotta subtract 29.75. So this is my absolute value inequality. Now to solve for this, I can take this out of the absolute value symbols. And when I do it, because I have a less than symbol, I know it's going to be a compound, or a conjunction compound absolute value or inequality. So I'm going to have this to be C minus 29.75 in the middle. It's less than or equal to 0.25 on the right hand side. And on the small hands, the lower end, it's going to be a negative 0.25. Now to get C by itself, I'm just going to add 29.75 to both sides. And when I do that, here I have 30 on this side, X or C in the middle, and C is greater than or equal to, if I subtract 29.75 and 0.25, I end up with 29.5. And those would be my ranges. But the question is asking, what is the least acceptable circumference? And the least acceptable circumference would be 29.5. I'm going to have you do the next example yourself. And your assignment for next time would be lesson 101, numbers 1, 6, 8, 19, and 20.